Hi folks, we're going to take a look at question 1 from the Unit 7 quiz. So let's start with A here. So we want to determine dy dx. So since y is given explicitly in terms of x, I can just go ahead and differentiate. Now, many of you will probably skip this first step that I'm going to do, but it might be helpful for those who still struggle a little with using the chain rule. Okay, and what might be helpful is tan squared, when we write this here, really represents the tangent of this input all squared. So it might be helpful to rewrite that here as tan, so in brackets, tan of x squared minus x all squared. Okay, so that's what this represents. Might be easier to apply the chain rule. Okay, so here let's determine dy dx. Okay, so first we have this expression squared, so this acts like our u variable. So first we take the derivative of u squared, which is 2u, so 2 times the tangent of x squared minus x. Okay, now we're going to multiply that by the derivative of this expression here with respect to x, so derivative of tan of x squared minus x, and again we're going to have to use the chain rule. So this time here, this is like our u. So the derivative of tan u would be secant squared u. So secant squared u, which in this case here is x squared minus x. And then finally, I have to multiply the derivative by the derivative of x squared minus x with respect to x. And that I can just do directly, so that's just 2x minus 1. Okay, so again here we saw that we had to use the chain rule 3 times. First for this expression squared, then the tangent of that expression, and then finally the derivative of x squared minus x with respect to x. Okay, and for a question like this, unless it says simplify, I just expect you to leave it in this form here. You don't need to simplify any further. Okay, let's take a look at B now. So here we can see that this is clearly a case where y is defined implicitly in terms of x. There won't be any way to solve for y explicitly, so we'll just use implicit differentiation. So here we'll take the derivative of each side with respect to x. So we'll start with the left-hand side. So again, this is y squared, so I'm going to have to use the chain rule. So first I take the derivative of y squared with respect to y, so that's 2y, and then I multiply that by the derivative of y with respect to x. So here I'll use prime notation, so I can save myself some writing. Okay. On the other side, again, we're going to have to use the chain rule. Okay, so first think of this as being your u value. So taking the derivative of cosine of u, which is negative sine u. So negative sine of this expression, x squared minus y squared. Okay, and then I have to multiply that by the derivative of that input, x squared minus y squared. So derivative of x squared, just 2x. And now, similar to what we saw before, we're taking the derivative of y squared with respect to x. So we use the chain rule again. First derivative of y squared with respect to y, 2y times the derivative of y with respect to x, which I'm going to use prime notation. Okay, so the next step in implicit differentiation is to group together all the terms that have a y prime. But I think I should probably simplify the left-hand side first. So, sorry, the right-hand side. So on the left-hand side, we've got 2y y prime. Okay, and on the right-hand side, I'm just going to distribute that expression to both terms. Okay, so the first one will be, so I'll write it as negative 2x, okay, times sine of x squared minus y squared. And then I'll multiply this to the other term. So this will end up being positive 2, okay, and then y sine x squared minus y squared times y prime. Okay. Now, first thing I notice is that all terms have a coefficient of 2, so we can just divide both sides by 2, simplify it a little, and now I'm going to bring together all terms that have a y prime. So since it's positive here, I'll leave this on this side, and this is negative, so I'll bring this expression to the left. So this will become positive x sine x squared minus y squared. Okay, and then on the right-hand side, I've got y times sine x squared minus y squared y prime. Okay, and this now bring it to the other side becomes minus y prime. Okay, and the reason for grouping all these together is now we can factor out the y prime on the right. Okay, so let's rewrite the left-hand side, and then on the right-hand side, we can factor out the y prime. So we're left on the left with y sine of x squared minus y squared minus y. And now we can isolate y prime. So y prime is just equal to x sine x squared minus y squared all over this factor here. So y sine x squared minus y squared minus y. Okay? And not really much else we can do. I suppose you can factor the y out here, but I don't know that that actually simplifies it. Okay, so here, a bit of work to do, but let's recall how implicit differentiation works. You just differentiate both sides of the equation here with respect to x and make sure that you're applying the chain rule where appropriate. Group together all the terms that have a derivative of y with respect to x and then isolate it. Okay, that's it for number 1.